let's take a look at a problem using what's called the chain rule for derivatives. Now, in this problem, we have x minus 5 divided by 2x plus 1. All of it is raised to the third power. Now, realize that because it's raised everything to the third power, we could split it up, make it x minus 5 quantity cubed divided by 2x plus 1 quantity cubed, and then we could use our quotient rule, low d high minus high d low, all over the square of what's below. That would be one technique, and that would be avoiding the chain rule. However, if we're going to practice the chain rule, let's use it. Okay, so if we're going to use the chain rule on this function, I'm going to introduce what's called a let statement and define a variable. And I'm going to define the variable u to equal the inside function. So I'm going to say let u equal the fraction x minus 5 divided by 2x plus 1. That rational function, a ratio of polynomials. Okay, so that means that our function is f of x equaling now u cubed. And realize that we don't have any x's now in the equation. They're embedded in the u variable here according to the let statement. Okay, so now we want to take the derivative. So we're going to try to find f prime of x. Now f prime of x, I'm going to take the derivative on the right side, which is the derivative of u cubed, which is 3u squared. Okay, but the problem is that we're trying to find f prime of x. We just took the derivative of something with u in it, and we need to bring it back into terms of x. And how we do that is with an operator. And the operator would be du dx, which means we have to find the derivative of u. And again, u, according to my let statement, was this rational function. So in order to find the derivative of this rational function, we are going to need that quotient rule here. And that's going to be this quantity, this operator, du dx. The 3u squared, the derivative is done. I am going to want to plug back in for u from the let statement at the end. But there's no operator here. That 3u squared, that derivative is done. So the only calculus left is the du dx. Okay, so my next step, and I'm going to keep that u present in that first quantity, 3u squared. Now I need the derivative with respect to x of u. What was u? X minus 5 divided by 2x plus 1. So operator tells the reader what we have to take the derivative of. I need to take the derivative of this quotient, x minus 5 divided by 2x plus 1, with respect to this variable x. Now in my chain rule, if I have the last term with respect to x, it looks like I'm done because again I'm getting everything in terms of the horizontal, okay, according to the Cartesian plane. Okay, so I'm going to follow the arrow up here. I have f prime of x equaling 3u squared. Again, we'll plug back in for u from the let statement at the end. Now I need to take the derivative of this quotient, okay, and again, that's where the quotient rule comes from, or is needed here. So I need low, which is 2x plus 1, times the derivative of the high function, so that's the derivative with respect to x of x minus 5. So I've got low d high minus the high function, x minus 5, times the derivative of the low function. So the derivative of the 2x plus 1. So it's low d high minus high d low, all over the square of what's below. So that's the denominator, 2x plus 1 squared. Okay, so again, I've applied the quotient rule for what was u to begin with from the let statement to do the derivative. So my next step, f prime of x is going to equal 3u squared. Still got to plug in for that u. Then I've got this quantity, so let's take a derivative here. I've got 2x plus 1. Now I need the derivative of x minus 5 with respect to x. Okay, and that's derivative is 1. The derivative of x is 1. The derivative of 5 is 0. So the derivative of x minus 5 with respect to x is 1. Minus now the quantity x minus 5. Now I need the derivative of 2x plus 1 with respect to x. The derivative of that is 2, again using that power rule. And again, don't forget about our denominator, that 2x plus 1 quantity squared. Okay, so this denominator is kind of all set up. Not much I'm going to do with it there. Chances are I'm going to combine it with something with u here. This numerator, though, I've got to collect my like terms. So I've got f prime of x is equal to 3u squared. Then I've got 2x plus 1, and that was times 1. I'm going to distribute the negative sign and the 2 over the x minus 5. So I end up with negative 2x plus 10. And again, all over the square of what's below, that's the 2x plus 1 quantity squared. Okay, continuing on, 3u squared. My numerator now, 2x minus 2x is gone. Looks like I've got an 11 up here, and that's divided by 2x plus 1, quantity squared. Lastly, I'm going to plug in for u. So I've got 3 times u. U is x minus 5 divided by 2x plus 1 squared. And then now I'm going to multiply times 11 divided by that quantity 2x plus 1 quantity squared. Okay, so at this step I have everything in terms of x. There are no operators. I have the derivative to the original function. The rest of it is organizing up to the answer at the back of the book, what your instructor's looking for. Okay, but I can see that I'm probably going to want to combine the 11 and the 3 because, again, the 3's out front. Everything's multiplication, as well as the 2x plus 1 that's squared here, the 2x plus 1 that's squared here. So my final answer is going to be 33 times the quantity x minus 5 squared divided by the quantity 2x plus 1. I'm going to add the exponent. This would be 2x plus 1 squared times 2x plus 1 squared. Same base. I'm going to add those exponents. So now we have an expression that has combined some terms for the derivative to the original function. And again, doesn't matter how elaborate your derivative looks, it's still the slope of the tangent line at an instant to your original function. Okay, and it still does what a derivative does here, no matter how complicated it looks. Chain rule and then the quotient rule.